Hello everybody, and well, I'm here back with an update with the 2 decimal calculator setup. Now, since the last video, all I've really done is I've just worked on adding in a RAM. Alright, so I've finished off the busing here. I've busted all down into a two-part RAM, or whatever you want to call it. So there's 8 bits on each side. That's the first side, and this is the second side. Obviously there's 2 sides, so that I can save the first number here and the second number's output here. Alright, now basically the way it works is the input comes in. Alright, so this is in the standard, or this is in the on state. The side 1 will save, or module 1 will save, whatever. So the signal will come from here and it will pass a signal through here. It will activate this T flip-flop or whatever it is, and then it deactivates that redstone wire, which then draws the pistons back up, causing it to save whatever information has been passed through here. Alright, and then the thing with this is once it's happened, or once the first number has been inputted and saved, what this does is it stops that signal from passing through again and creating problems or whatever until it's reset. Oh no, it is reset right now. So it's a similar deal for the second side, but what's happened is instead of using a T flip-flop, I've used a vertical XOR gate, so that once the signal comes through the first number's been selected, that passes up and around into the bottom side of the XOR gate. Alright, and then that triggers the bottom side of the XOR gate, and then when the next number passes through here, that signal's taken again and run to the top side of the XOR gate, and then once both of them are activated, it will send a redstone wire down here to save the number input, and then they'll retract again, which will save the number. Okay, so what else I've done is I've bust all of these back into, so you've got the first number input here, the second number input there. I'll bust them all down into one button. Okay, and it's simple, very easy to do that. Just put a repeater behind this block, and it will push the signal through the block and on top of the block as well, I guess. And so yeah, that's both numbers being bussed into one button. Alright, so what I'm going to do is I'm going to quickly press a button to demonstrate how it works. At the moment you can still see a signal here because I haven't built a reset button into it yet. I guess I'll build a reset into it later on, but here's fine because that has been reset. Alright, so the bottom line is the first decimal, top line is the second decimal. I'll put number 27, I'll save number 27 into it. So that's 2 plus 7. And here we have the answers come through now. So that's number 16 on binary, that's binary number 8, 16 and 8 is 24, add 2 is 26, add 1 is 27. Alright, and so now we will do, let's just make a nice easy number, we'll do 8, 12, we'll just do number 12. And there you have it, there's number 12 has come through there. So it's we've entered the first number 27. It saved it into the first RAM module, and now we've entered the second number as 12, which has saved that into the module as well. And then after the RAM, it will be bussed off into the adders to add both the numbers to get the final answer. Alright, but because I'm going to be building a display as well, so you can see which number you've first selected, so 27, I'm going to bust it off, I guess, and figure out how to turn this binary output into an input that a display can read. And the same with this number, so that you can see which numbers you've picked, and then when they press the equals button, by the time both these numbers here, the calculator's already added them, but you've just got to press the equals button to get the answer to come through. The reason why I want to work it like that is, so that people aren't pressing the equals button and then just standing around for 20 seconds waiting for the answer to come through. I've seen a lot of redstone circuits and stuff where the delays are just so huge, and it's just silly, because it's so big. But anyways, that's all I've done this round. I've just bust all of these numbers. I've come through the enabler and disabler, and then I've busted all back into one space between them all, I guess. And so yeah, connected them all together to get the one button input, which is what it's going to be. Alright, and yeah, I've got the RAM sorted out. If you want any help with the RAM on the way I set it up, whatever, just post a comment and I'll do a more defined video and show you, I guess. But yeah, that's basically all I've added since the last video. Alrighty, guys. Oh yep, and I've added all of the timing, I've added all of the reset. So I want this to automatically reset once the first input's punched through. I want this to automatically clock the flip-flops. So that's basically what this wire is doing. It's taking that, and once any of these torches are lit, which will happen when any of the buttons are pressed, it shoots a signal along that redstone wire and down into there, which clocks them while the signal is being pushed through. So that's what this delay is, which is set to 3 ticks or whatever. It delays that signal so that the signal is being pushed through the D flip-flop while it's being clocked. Alright, and yeah, that's about it. And here, after the signal comes through here, because the signal only will come through here after both numbers have been selected. So after both numbers have been selected and the signal comes through, it passes along this bus here, which then clocks the flip-flops again, and because there's no input, it clocks them back to the off state. Alright, so that's what that one does there. So yeah, anyways, alright guys, that's the video. I'll make another one soon and post it up for you all to see. Thank you.